I did go on and post it anyways. There is no audio attached to it because I realized at the end the headset was never turned on. So the video is still there. You can still watch the entire process of how we solved them, how we got to the answer, but there is no audio attached to it. And there shouldn't be any high piercing screeching noises because a few of the videos when the headset's not turned on, it makes a loud noise. It's not there. It shouldn't be there. If it is, let me know. I can go back and fix it. But before we start this one here, because I think this is where we left off yesterday. Yes? Are there any questions on homework before we start this here? Now we're going to start with this one here. We want to find the difference. All right, guys, let's focus in. We want to find the difference between these two here. And with addition or subtraction, sum and difference, the first thing we really need to do is to factor the denominators. We need to factor the bottom of these rational expressions as far as they possibly can go. So if we look at these two here, 2x minus 2, what can we do to factor it? We can factor the 2 out. It has a greatest common factor of 2. And it'll turn our 2x into x, and I'll turn our 2 into 1. Questions on this here? Let's factor our x squared minus 4x plus 3. Is there a greatest common factor? No. Well, we'll have 2 sets of parentheses with 3 spots. Since our third term is positive, our signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared, x and x. Factors of 3 are 1 and 3. Questions on this here? And I feel like getting to this point, we feel comfortable. Yes? Getting to this, we feel good, factoring. And probably one of the big spots that we're having trouble with is least common multiple, least common denominator. Yes? Okay, I'm going to take it at a different approach this time. Because we know to get these to be the same, we're going to have to multiply both of them on top and bottom by an expression so the denominators are the same. So the bottoms of the fractions are the exact same. Yes? Let's look at it this way. I'm going to start with the one. I'm going to get a different color. Let's do this green. We're going to start with our 2 times x minus 1. So looking at it, what is it missing that the other denominator has? X minus 1, yes? So the 1 on the left. So, because it has a 2, yes? This one, that's fine. Doesn't have a number. This one has an x minus 1. This one has an x minus 1, yes? So what it has, nope, we'll get there in a second. Because if I look at the one on the left, it has a 2, it has an x minus 1. The other side has an x minus 1. But this side over here does not have an x minus 3. So for them to be the same, the one on the left needs an x minus 3. Yes, because then we can go the other direction. I'm going to erase all this writing. Because if we look at it the other way, we're looking at what is this missing that this one has. Because we're looking both directions, trying to get them to match up. Well, the one on the right, sorry, the one on the left has a 2. The one on the right needs 2. So we're going to multiply on top and bottom by 2. So if we multiply our denominators, and we'll do the numerators here, the denominator we'd have 2 times x minus 1 times x minus 3. On the other side. Now the two denominators are the same, yes? So our least common denominator if we went through that process, it would be 2 times x minus 1 times x minus 3. Now we are going to multiply the numerator. We're going to write it out first because we'd have x minus 3 times x plus 2. On the other side, we're going to have 2 times negative 2x minus 1. Let's focus in here, guys. Because the one on the right is going to be a little bit easier to multiply through than the one on the left. Because we're going to do 2 times negative 2, which is negative 4x. 2 times negative 1, negative 2. Let's focus in here, guys. Because when we distribute that 2, it's just multiply, multiply. Now, multiplying through with just that 2, we could have done that in the previous step because we're doing 2 times negative 4, 2 times negative 1. The other side, our x minus 3 times x plus 2, you could do it in the previous step, but we just need to make sure we do distribute completely. Because we have to do our x times x, which is x squared. X times 2 is plus 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. We have to distribute it completely. Questions on how we got to this point here? Now, we won't do too many of these where we have a quadratic being multiplied or we're having to multiply the numerator by a quadratic, a 3-term. But especially with those where we have more than one set of parentheses being multiplied by the top, it's sometimes good to write it out part by part. Because we sometimes get a lot of terms and it's easy to get them mixed up or misplace them. Now for the left-hand side, we do have like terms. X squared does not, but our 2x minus 3x is minus 6 minus questions on how we got to this point. Now, yesterday I said putting parentheses around our sum when we're adding two rational expressions is not overly important. You can do it. It's not going to hurt anything. If you don't do it, it's not going to hurt anything. But we do need to be careful with subtraction. Because when we go to subtract these, we have to be careful with the signs. Our first set of terms, our x squared minus x minus 6, signs are not going to change. Yes, because when we subtract negative 4x, when we subtract a negative, it becomes positive. So our minus negative 4x is going to become plus 4x. Our minus negative 2 is going to become plus 2. Because we have to distribute that negative through. We have to apply it to each term. Now, when we do that with plus, or our positive, our plus sign, well, it just keeps the signs the same. It doesn't change anything. But our negative does. And that's what we have to be careful with. Questions on how we got to this point here? We're almost done. Because as we can see here, do we have like terms? X squared does not have any like terms, so it's just x squared. Negative x and 4x, negative x plus 4x is plus 3x. Negative 6 plus 2 is negative 4. Questions on how we got to this point? Now, the last thing we need to do before we can say we're done is make sure that our x squared plus 3x minus 4 does not factor. If it factors, we need to factor it. Even if it doesn't simplify it with anything, we still need to factor it. So if we want to check our b squared minus 4ac, 3 squared minus 4 times 1 times negative 4. Now the value we get from this, we're really just checking. This is to check if it's factorable. It is part of the quadratic formula, and for us to have any meaning from this number, we'd have to have the rest of it. We'd have to have our negative b over 2a, but, well, that's convenient. Square root of 3 squared minus 4 times 1 times negative 4 is, I did this problem yesterday. Yeah, so it's already typed in, I didn't clear it out. But it's already plugged in and we get 5. So it's factorable. Now, I did have some questions, so is it going to factor 5? Well, no, because this is part of the quadratic formula. So we would need our negative b, so negative 3 plus or minus 5 all over 2a to actually get somewhere with it, for it to actually have meaning. Does that make sense? So this here, we're just using it to determine, does the numerator factor? And it does. Yes. Now, since the 4 is negative, our signs are indeed opposite. The only set of factors for x squared are x and x. Factors of 4. Yes. So we do want 3, so 1 and 4 is probably a good choice. Also, if we look at the denominator, if something's going to match, it's either going to match with x minus 3 or x minus 1. Well, 3 is not a factor of 4, so that possibility is gone. X minus 1, well, we do have a 1. So that's another reason we can choose 1 and 4. Now we can check it just to make sure. X times negative 1 is negative x. 4 times x is plus 4x, which does give us a positive 3x. Yep. So we do have something in common on top end. So they cancel out, leaving us with yes. I will say this, and I think y'all have noticed with most of the problems we do in here, it takes forever for me to go through and explain and us to work through it, and it normally takes about half that time or less for y'all to just work it on your own, to where we're not pausing and stopping and y'all can keep rolling. Questions on this here? Now there are steps, I mean, especially we could have skipped, especially writing it out, because we could have gone from here to here, especially with the 2. I would be careful doing from here to here, as long as you're making sure to distribute through. Because if you remember to distribute through, we can get to here. We don't necessarily have to rewrite with them next to each other. But if that helps you writing this middle step, do it. Do it. Doesn't matter which one we factor first. Which one do we want to factor first? 2x minus 4 has the greatest common factor of 2. And if we factor it out, we get 2 times x minus 2. X squared minus 3x plus 2. And again, there is no greatest common factor. I have a tendency to gloss over that. And just a reminder, one of the quick kind of giveaways is the first, middle, or third term. If any one of those 3 has 1 in front of it, so it's just x squared or x, or just plus 1 or minus 1, There is not going to be one. Third term's positive. Signs are the same and match the sign of the middle term. Factors of x squared are x and x. Negative 1 and 2. Questions on what we've done so far? I also want to take a guess and make an assumption that the way we did the last one to make the denominators be the same was easier than what we did yesterday. A little bit. Because the first thing we're going to do is we can look at the one on the left. What is it missing that the one on the right has? 2. It's missing a 2. So we're going to multiply it by 2 on top and bottom. Now what does the one on the left have that the one on the right doesn't? X minus 1. The only reason, so we have x minus 2 in common, yes? The only reason we'd have to multiply both sides by an x minus 2 is if one side had 1 and the other side had 2. If it had x minus 2 times x minus 2, then we would need it twice. But since it's only listed once in both, you don't have to list it again. So our denominators are going to be 2 times x minus 1 times x minus 2. Now our numerators, we're going to multiply them together. Now at this point we can multiply out 2 times 5x is 10x. 2 times negative 1 is negative 2. Well, we have negative 2x times x. Negative 2x squared. Negative 2x times negative 1 would be plus 2x. Negative 1 times x is negative x. And lastly, negative 1 times negative 1 is plus 1. Combine like terms. Let's focus in. 2x minus x would be plus x plus 1. Questions on this so far? I think we feel good with this. Yes, feel better than yesterday. Now at this point we can subtract. Now our 10x minus 2, the signs are not going to change. In our second set of parentheses, every sign is going to change. Because when we apply it to our negative 2x, it's going to become plus 2x squared. When we apply it to our x, our positive x, it's going to be negative x. And we apply it to positive 1, it becomes negative 1. It changes the sign of all 3 terms. Questions on any of this here? Now we do have 10x and negative x. 10x minus x is plus 9x minus 3. When we were starting to simplify this down, when we had that 2x squared, I thought there was a chance Even though I've done this problem before, it's been a little bit. Can't remember if I did this yesterday. I was hoping that that would be a greatest common factor 2 would simplify out. But 9 and 3 tell us otherwise. Now there's a good chance these, the numerator is going to factor. But there's also a good chance that it won't. Before we start this, let's go on and check it. Because that would be 9 squared minus 4 times 2 times negative 3. It doesn't. So that's as far as it goes. Because we could go through the process of doing 2x, and the closest we can get to is 7x as our middle term. So it doesn't factor. Even if it did, there's a good chance it wouldn't match up with either denominator. And even if it doesn't, it factors and it doesn't match up, still factor it. Questions on this here? No, but it'd be better to go on and factor and see. Because if there is a like term, we have to remove it. If there's not, we already have it in factored form. So, and if it's already in factored form, there's no reason to undo that step. Leave it as that there, if that makes sense. And that's the same thing with any of them. If we get down and the answer is x plus 3 times x minus 3, you do not have to write it as x squared minus 9. Leave it as factored form. Let's look at number 6. This one here, I was looking back at the note sheets and I'm like, this one I probably should have started the lesson with. Well, we can do the same thing that we did before. Now we do need to be careful with numbers because 4 and 7. Because again, we need to find the first number we can turn both 4 and 7 into, and it's 28. So it ends up being we have to multiply the 7 by 4 and the 4 by 7. That's the first number we get.
But also it needs to be 4x.
Yes. And this side needs to be 4x. And the reason we end up doing this, and you're looking at this y, it's just multiplying the left side by the denominator of the right, and the right side by the denominator of the left, yes? 7 and 4x, do they have anything in common? If we were to take a greatest common factor out, do they have one? No. And that's really kind of the heart of some of these. The previous one had a greatest common factor of x minus 2, so we're not multiplying by that pure denominator. Does that make sense? Because if we did, we add an extra factor of x minus 2 on top and bottom, and it's guaranteed to be removed. And it's going to make things harder. Because instead of having a quadratic, x squared, we'd have a cubic. We'd have that extra x minus 2 on top and bottom. That has to come back out. That's why we try to find this least common denominator. Does that kind of make sense? Here, this one's kind of nice. 7 times 4. Well, 28x, 28x. 7 times 3. 1 times 4x. Since we have the like bases, we can subtract the numerators, yes? Now, since it is a single term in both spots, we don't necessarily need the new parentheses here because what we're subtracting has one term. We're applying it to 1. We put parentheses on the last because I had 2 or 3. I had multiple terms that negative is having to go to, yes? Here, I can go on and put them, and I'll show you this here. Well, then when we drop them, we get back to here. So if we put the parentheses, then we remove them, we apply the negative to the 4x. and we're back where we were. Does that make sense? If you're not sure if you need them or not, put them. You're not losing anything if you put them. If you put them and don't need them, you drop them, you're back where you were. If you don't put them and need them, it makes things a little harder because then you don't put the negative with every term. Makes sense? Okay. Is there a greatest common factor between 21 and 4? Now, yes, there is another way we could technically write it. I'd be putting the x in front. You can put it either way. I'm not going to specify. Yeah, that's if we were wanting it in standard form. But a lot of times, even with this, because we're leaving the x negative, they will put it in the back just to make sure we don't lose track of that negative. That's it. I'm going to fix the notes sheet and put that one closer to the front, not to the back. Questions on these here? Do we feel better about these? Yes? Because the big thing with sum and difference, factor the denominators, get them to be the same, and then reduce. We do have time for at least one or two more. Okay. We have 3 left. I'm going to let y'all pick which one we do.
Okay,
Last one?
Yeah, we might as
So,
well.
yes. Now, the note sheet, I realized, especially looking back at it, one of the numerators did not print well. I went back over it in a darker ink and fixed it. But what I'm going to do first is, well, we do need to factor all the ones that are factorable. All the denominators that are factorable, we need to factor. Well, the first one, x plus 4, simplified as it gets. Plus 2 over, yeah, thank you, x minus 4 is as simplified as it gets. Our middle term of x is as simplified as it gets, yes? When you put that in there, do leave a space because we're going to have to multiply not just both, but all 3. We need to get all 3 denominators to be the same. So I'm going to leave a space. Yep, you can leave it behind it, the 2 over x, or in front of the 2 over x. We just need somewhere to multiply in the middle. Minus 2x squared plus 8x. And as tempting as it is to want to factor our 2x squared plus 8x, we leave it alone. Because as we've seen on all these here, once we get the denominators the same, we're having to combine like terms for the numerators. We have to actually add or subtract. So if we did factor the 2x out, we'd have to multiply it back through for us to be able to add or subtract. X squared minus 16. X plus 4 and x minus 4. Okay. So if we look at our first one, it has an x minus 4. But one of the others does have an x minus 4 and an x. So this first one's going to need an x plus 4 on top and bottom. Is there anything that the middle one has that our far left one doesn't? So we'll also need an x. So we do the same thing. We're just doing it with 3 denominators. Do we want to look at the middle one next or the far right? Far right. So the far right has an x plus 4 and an x minus 4. Is there anything that the middle one has? X. X over x, yes? Far left, is there anything it has that our far right doesn't? No. Far left has an x minus 4, but it only has it once. The one on the far right has an x minus 4 once. So that's it. Yes. Because that's what it's missing completely. Now I'm going to show you something that you're going to like, and it's going to save time. And I'm going to show it on the middle one first. So we're going to do the middle numerator first. So I am a fan, especially once we get an understanding of this, in skipping steps in place we can skip steps. Yes? So the middle term, we're multiplying the numerator by x plus 4 and x minus 4, yes? Where did we get the factors of x plus 4 and x minus 4 from? So we got those factors from this here, yes? So what should these two multiply back together to give us? That works with any of them. Even if it's not just a difference of perfect squares. If we factored one of them to x plus 3 times x minus 2, and one of them I'm having to multiply x plus 3 and x minus 2, where did we get it from? We got it from, it'd be x squared plus x minus 3. It's going to go back there. We can just fill that back in because we already have it. That's where we got them from. Now our other ones, how we multiply the one on the left out, there's not a big difference to it. The one I will leave alone for now is the x minus 2. But what are we multiplying it by? X times x plus 4, yes? What's x times x? I'm just moving the x in. Does that make sense? Because some of these simple one step where we're just multiplying a single term, we will. We're just not there yet. And even for me, when I do these and I work through these, that's one step I will do. I'll multiply the x or that single term into one of them. I won't do both because it's a lot to keep track of. Because most of the time when I do that, it's x times x. We're good. I'm having to also keep track now of x squared times x squared times negative 2. 4x times x, 4x times negative 2. And it's easy to misplace a power, a variable, a term when we start doing too much. And I feel that just the single x, we're just adding to it, is not a whole lot. But we can see when we add the other one to it, it's now taking it a whole step higher. Same thing's true over here. 2x squared times x is now 2x. And our 8x times x is 8x squared. That's a nice little step. I'm trying to see where we're at. Here? Yes. That's what we're going to do next. Because we do have two places that we do need to simplify. One of them is in this first spot. We do need to simplify in the middle. And luckily for us, the third one is already simplified. The numerator is. There's no like term, so we're not going to mess with it till we start actually combining the fractions. X squared times x is x to the third. X squared times negative 2 is negative 2x squared. 4x times x is plus 4x squared, and 4x times negative 2 is negative 8x. Questions on that first rational expression? Now we will need to combine those two middle terms, which is really just going to get us to x cubed plus 2x squared minus 8x. Now we do need to multiply the middle term. 2 times x squared is 2x squared. 2 times negative 16 is Yes. I don't know about y'all, but I have a feeling most of y'all are tired of writing x times x plus 4 times x minus 4. Well, luckily, in the next step, we only have to write it once. Yes. Yes, thank you. That would have thrown everything off. Now, we write it with parentheses just to change the last two terms. Combine like terms. Questions? Because I know I'm getting a little quick. Because the negative, when we're subtracting that last term, the 2x squared, or not 2x squared, 2x cubed becomes negative.
First one, -8. Shouldn't there be an x after it?
Yes, thank you. And unintentionally, that's also why I don't like trying to do too many steps at once, because that right there is very easy to do. Yes. Now, if you feel comfortable keeping track of that, especially since it's just the one turning the two signs, now, if you need to go up the page, you can, because we do have the one above it, as long as you draw an arrow or specify, because I think the problem above is empty. Let's look at terms. X cubed minus 2x cubed is negative x cubed. 2x squared plus 2x squared. Negative 4x squared. Questions on this here? Okay. Well, this isn't the answer. I'm going to give this t negative yes. If you want to hang out a second and see this to the end, I pulled a negative out to make it easier to work with. Now, yes, factoring by grouping, because we got 4 terms. X squared is in common with the first 2. Sorry, I know I'm going a little bit quick. Yeah. And the only reason we do this is 8's in common with the last 2. It shows out a common factor of x plus 4. Yes? Yeah. And lo and behold, now I will show you this. It is in Google Classroom, the homework attached to this. There is one like this on the homework, but it ends there. I had to finagle and mess with the numbers to get this one to factor at the end. Those on the homework, once it's done, once you get here, it's finished.
Is this the chapter we had twice?
Yeah.
Okay. It's not that bad. You think that? You think that? I feel like we all.
Then